Production function. So firstly, we should know the meaning of production function. Processes and methods employed in transformation of tangible inputs, raw materials, semi-finished goods or sub-assemblies, and intangible inputs, ideas, information, know-how into goods or services is called production. Production function is a function that specifies the output of a firm, an industry, or an entire economy for all combination of inputs. Almost all economic theories presuppose a production function either on the firm level or the aggregate level. The way that businesses create products and services is known as the production process. There are three main paths to the production process, as can be seen in the diagram. A firm must purchase all the necessary inputs and then transform them into the product or outputs that it wishes to sell. For example, a football shirt manufacturer must buy the fabric, pay someone for a design, invest in machinery, rent a factory and employ workers in order for the football shirts to be made and then sold. How well organized a firm is at undertaking this transformation process will determine its success. This is known as the productive efficiency of a firm, and it will want to be as efficient as possible in transforming its inputs into outputs. That is, using the minimum number of inputs as possible to achieve a set amount of output. This will reduce the cost per unit of production and allow the firms to sell at a lower price. Ultimately, the objective of the production process is to create goods and services that meet the needs and wants of customers. The needs and wants of customers will be met if a business can produce the correct number of products in the shortest possible time to the best quality and all at a competitive price. Managers are required to take different but interrelated production decisions like whether or not to actually produce or shut down, how much to produce, what input combination to use, what type of technology to use. After studying this lesson, you should be able to analyze the production function, short run and long run, understand the concept of isoquants, determine marginal rate of technical substitution, calculate the optimal factor combination, analyze the concept of returns to scale, analyze the concept of economies of scale and economies of scope. In a general mathematical form, a production function can be expressed as Q equals to F x1, x2, x3 till xn, where Q equals to quantity of output, x1, x2, x3 to xn equals to quantities of factor inputs such as capital, labor, land, or raw materials. Two types of input available for production are variable input. Variable input is an input whose quantity can be changed in the time period under consideration. The most common example of a variable input is labor. Variable inputs provide the means used by a firm to control short-run production. The alternative to variable input is fixed input. A fixed input like capital provides the capacity constraint in production. As larger quantities of a variable input like labor are added to a fixed input like capital, the variable input becomes less productive. Now let's discuss two types of production function, which are short-run production function, long-run production function. A decision frame in which one or more inputs are held constant may be used. For example, capital may be assumed to be fixed constant in the short run, and the labor and possibly other inputs such as raw materials variable, while in the long run, the quantities of both capital and other factors that may be chosen by the firm are variable. In the long run, the firm may even have a choice of technologies represented by various possible production functions. The analysis of short-run production sets the stage to better understand the supply side of the market. How producers respond to price depends in part on their ability to combine inputs to produce output. This ability is guided by the law of diminishing marginal returns, which states that the productivity of a variable input declines as more is added to a fixed input. With more the variable input needed, the cost of production rises, and as the production cost rises, the price that producers need to receive also increases. Hence, a higher price corresponds with a larger quantity, which is the law of supply. The positive law of supply connection between price and quantity as such can be traced to the law of diminishing marginal returns. With the above discussion, we must also take a view of three stages of production: increasing marginal return, decreasing marginal return, negative marginal return. Increasing marginal returns occur if each additional unit of a variable input added to a fixed input causes incremental production to increase. For example, the one worker contributes 10 units of output to production, the next worker contributes another 12 units, and the subsequent worker contributes 14 units. With increasing marginal returns, each worker contributes more to production than the previous worker. Decreasing marginal returns occur if each additional unit of a variable input added to a fixed input causes incremental production to decrease. For example, the one worker contributes 10 units of output to production, the next worker contributes another 8 units, and the subsequent worker contributes only 6 units. With decreasing marginal returns, each worker contributes less to production than the previous worker. Negative marginal return results if the addition of a variable input added to a fixed input actually causes the total production to decline. For example, if 10 workers produce a total of 100 units of output and 11 workers produce a total of 99 units, then the 11th worker is said to have negative marginal returns. Let us discuss three important concepts used in such an analysis. They are AP, MP, and TP. The graph shown on the slide presents the three product curves that form the foundation of short-run production analysis. The curve labeled AP is the average product curve. The one named as TP is the total product curve, while the MP curve is the marginal product curve. Till now, we have studied about the short-run production curves. Now let us move ahead to the long-run production function of a firm. This is also known as an isoquant. An isoquant, derived from quantity and the Greek word iso means equal, is a contour line drawn through the set of points at which the same quantity of output is produced while changing the quantities of two or more inputs. Isoquants are typically drawn on capital labor graphs, showing the technological trade-off between capital and labor in the production function and the decreasing marginal returns of both inputs. Adding one input while holding the other constant eventually leads to the decreasing marginal output, and this is reflected in the shape of the isoquant. A family of isoquants can be represented by isoquant map, a graph combining a number of isoquants, each representing a different quantity of output. Isoquants are also called equal product curves. Isoquants show the four characteristics. They slope downward to the right. It is convex to origin. It is smooth and continuous. Two isoquants do not intersect. There are four types of isoquant curves. Linear isoquant. This type assumes perfect substitutability of factors of production. Input-output isoquant. This assumes strict complementarity, that is, zero substitutability of the factors of production. Kinked isoquant. This assumes limited substitutability. Smooth convex isoquant. This form assumes continuous substitutability of certain range. Now let's look at isocost lines. The isocost line shows the combinations of capital and labor that will end up costing the same amount. If a firm uses only labor and capital, the total cost or expenditure of the firm can be represented by C equals to WL plus RK, where C equals to total cost, W equals to wage rate of labor, L equals to quantity of labor used, R equals to rental price of capital, K equals to quantity of capital used. Now let's discuss marginal rate of substitution. The marginal rate of technical substitution, MRTS, or technical rate of substitution, TRS, is the amount by which the quantity of one input has to be reduced when one extra unit of another input is used, so that output remains constant. MRTS x1 x2 equals to minus delta x2 divided by delta x1 equals to MP1 divided by MP2, where MP1 and MP2 are the marginal products of input 1 and input 2 respectively. Along an isoquant, the MRTS shows the rate at which one input, X for example capital or labor, may be substituted for another while maintaining the same level of output. The MRTS can also be seen as the slope of an isoquant at the point in question. Now let's discuss return to scale and its related concepts. Firstly, start with the meaning. Returns to scale and economies of scale are related terms that describes what happens as the scale of production increases in the long run, when all input levels including physical capital usage are variable chosen by the firm. The term returns to scale arises in the context of a firm's production function. It refers to changes in output resulting from a proportional change in all inputs, where all inputs increase by a constant factor. If output increases by the same proportional change, then there are constant returns to scale, CRS. If output increases by less than the proportional change, there are decreasing returns to scale, DRS. If output increases by more than that proportional change, there are increasing returns to scale, IRS. Thus, the returns to scale faced by a firm are purely technologically imposed and are not influenced by economic decisions or by market conditions. A firm's production function could exhibit different types of returns to scale in different ranges of output. Typically, there could be increasing returns at relatively low output levels, decreasing returns at relatively high output levels, and constant returns at one output level between those ranges. These three types of scale occur because of various reasons, which are economies and diseconomies of scale, which changes from time to time. Now let's discuss some other concepts. Firstly, elasticity of substitution, which is the elasticity of the ratio of two inputs to a production or utility function with respect to the ratio of their marginal products or utilities. It measures the curvature of an isoquant. In other words, it is the proportionate change in the ratio of two commodities to the proportionate change in their price. EXY equals to percentage change in commodity quantity ratio divided by percentage change in commodity price ratio. Next one is the economies of scale, which refers to the cost advantages that a business obtains due to expansion. There are factors that cause a producer's average cost per unit to fall as the scale of output is increased. Economies of scale is a long-run concept and refers to reductions in unit cost as the size of a facility and the usage levels of other inputs increase. Diseconomies of scale are the opposite. The common source of economies of scale are bulk buying, managerial specialization, new marketing tactics, etc. There can be internal as well as external economies of scale. And another one is economies of scope, which are conceptually similar to economies of scale. Whereas economies of scale primarily refer to efficiencies associated with supply-side changes, such as increasing or decreasing the scale of production of a single product type, economies of scope refer to efficiencies primarily associated with demand-side changes, such as increasing or decreasing the scope of marketing and distribution of different types of products. Economies of scope are one of the main reasons for such marketing strategies as product bundling, product lining, and family branding. Now the last topic for discussion is returns to scale versus returns to a factor. When we refer to the impact of a proportional change in all inputs on the level of output, we mean the returns per scale. But when we refer to the impact a change in one variable input given the other fixed input constant, we mean the returns to a factor. The input elasticity of output indicates the returns to a factor, but the function coefficient indicates the return to scale. The information about returns to scale can also be used to derive conclusions about returns to a factor. If there are DRS, the returns to a factor must be diminishing. If by changing both the inputs we get diminishing returns to scale, by changing just one input we must get more pronounced diminishing returns to a factor. If there are CRS, the returns to a factor must be diminishing. If by changing both the inputs we get CRS, by changing only one input we are bound to get diminishing returns because we are now using less quantity of inputs. If there are IRS, the returns to a factor may be increasing or may be decreasing. It will all depend upon the degrees of IRS. If IRS are prominent, the returns to a factor may be increasing. If IRS are moderate, the returns to a factor are more likely to be diminishing. Now let us check if we have understood the various concepts discussed in this lesson clearly. Variable inputs are those inputs that can be varied easily and on very short notice. Right or wrong? Right. In the short run time period, only one input is fixed. Right or wrong? Wrong. Increasing returns to scale are due to technical and/or managerial indivisibilities. Right or wrong? Right. Linear isoquant is that type assumes partial substitutability of factors of production. Right or wrong? Wrong. Now let's revise what we have studied till now. Production means conversion of inputs or resources into usable commodities or services. Inputs are the resources used in the production of goods and services and are generally classified into three broad categories: labor, capital, and land or natural resources. Production is a process in which economic resources or inputs are combined by entrepreneurs to create economic goods and services. The law of variable proportion says that as more and more of the factor input is employed, all other input quantities remaining constant, a point will eventually be reached where additional quantities of varying input will yield diminishing marginal contributions to total product. In the long run, all factors of production become variable the distinction between fixed and variable factors become irrelevant. The production in long run can be increased by increasing all the factors of production.